Hello guys, I just like to share with you my very simple low current sensor, AC current sensor for my charger. So this is an example for AC current sensing while triggering the DC output cut off galvanically. So it's isolated and using the Fairly M3050 AC current switch. So I'm using this 80 amperes 12 volts power supply, which is variable. I adjusted it to 13, I guess. Max charging voltage 14.6. I adjusted this one for 13.6 just for the test, and now it's charging. And also I do have a very small wire, so I can't maximize the output current or the charging current if I raise the voltage up higher. So as for the moment, we are at 12.9 volts DC and we're still charging. So this is our charger. It's an 1000 watts power supply, approximately 80 amperes, and so it's a very simple switch. So this battery is powering up this relay, yet so positive terminal goes to the switch of the relay with the connection of the switch here for the AC current switch, and the other side, which is switch here on and off, is from the positive terminal of the power supply, and the negative is there just directly connected towards the battery terminal, the negative battery terminal of the battery. And this one is the positive terminal, or the other coil terminal of the relay. It's a 12 volts relay. So basically this thing uh, switch on or shorted. This is now shorted if it senses a very high current in the uh, high current, I mean a certain current setting based on the trimmer I have adjusted on the AC side, and this one is controlling the DC side, so it's very isolated. Yeah. As you can see, it's using a AC current sensor. Now it's controlling this relay through the power supply of the battery. So okay, it's just turn on and off. So we'll to a charge for quite long time now. We will try to change the current setting of the this AC current sensor. So if we go counterclockwise, it sends a very low current and turn on. So if we do the clockwise rotation, so it will sense a it will set into a higher current sensor. So if we do set the trimmer at much higher current than it sends, it will turn off the uh, switch here, the K1 and K2. So we'll try to turn it to clockwise until such time that we will sense E of yon. Now it's no longer charging because it do sense we set the AC current input to a higher level. Okay, so now I do that because in charging battery we can never rely on the voltage itself. So you just set a voltage there, and if you rely on that certain voltage, like this guy, wait, like this one, so we can never rely on this one because this one is based on voltage. And so we're charging current with respect to the voltage. So eventually, if a certain voltage is attached to the battery or the load, and it reaches up to the certain voltage closer to the battery, and the the current needed, or the current needed, inrush current needed for the battery is lower and lower, to such time it will no longer charge. So it will turn off the relay itself through the input AC current. So yeah, it's a very effective charging device. Yet you still need um, to set the current setting for this one. So I suggest you can use clamp meter like this one, or anything that comfortable with you. You can sense the current here, or maybe the current here, for the accurate reading at certain point. Yeah, you can change, adjust the voltage value here. Let's say I'm gonna uh, boost up the voltage, so eventually it will charge up. No, yeah. Now to start up the battery, it needs to connect to the battery for this one to sense there's a current load there. See, so we need to lower the current sense, and then crank it up again, short it there, so it sends. Now if we lower the voltage, of course it will have a very close voltage difference, or both voltage potential between the charger and the battery, and the current sense will be lesser and lesser. So we'll lower the voltage, and it will eventually turn off the relay. There. Now if I need to charge it, this guy again, cut up the voltage to your desired voltage, and then short this one just to start up the system. So if the battery is full and then you need to charge it again, you need to short this terminal. You can use inrush current sensing, or maybe just put a resistor or NTC in there for temporarily cranking up or detecting the current. Okay, so guys, I hope you understand. So I'm trying to speak in English so that other viewers from other country would understand what we're talking about here. So basically, we are sensing the input current, AC current from the charger, uh, through the DC current charging of the battery. So we are using AC current sensing to get to sense the DC current of the battery. If it gets lower, it just shut off the relay. So it's a very useful device for a very simple, a crude setup for the battery charger. It's not automatic, but it will do the job. Okay guys, thank you for watching, and this Video Tech Power Amplifier YouTube channel, and this is my bench at the house. I do have my Kenwoods and my Rigel. Okay, that's it guys, thank you for watching, and yeah, more solar setup soon. We'll talk about this one. Okay, bye.